Evening, guys. This is going to be a first in a two-part video on topic 5 of Unit 2, which is ionic Lewis dot structures. The second part will be on covalent Lewis dot structures. So let's get started. Ionic bonds form between metals and nonmetals, so that's how you'll be able to spot it. And when these bonds form, the metal reaches its noble gas state by losing electrons, which turns it into a positive ion. For instance, if I had sodium, which is a metal, and just as a reminder, its electron configuration is this. If it loses this one electron here, it reaches a noble gas state of neon. So the way we're going to represent this in these pictures is we're going to show that sodium had one valence electron by putting one dot on the sodium. And in the structure, it should give that dot away and become sodium plus with no dots around it. Now, it does now have 8 valence electrons, but we're not showing 8 dots around this because it reached that by giving away its one extra one. So in a correct Lewis dot structure, all of your metals should have no dots shown around them and positive charges. The nonmetals are just the opposite. They gain electrons and form a negative ion. So if you had a Lewis dot structure involving chlorine, 1s2, 2s2, 2p6, 3s2, 3p5, if it gains an electron and goes from 3p5 to 3p6, it has now reached a noble gas state of argon. So the way we'll show this on our Lewis dot structures is chlorine started out with 7 dots because it has 2, and this was a 5. It had 7 valence electrons, and it's going to gain electrons until it gets to 8 with a negative charge. So all of your nonmetals should end up with 8 dots and a negative charge. The bond is then formed because these opposite charges hold these together. Let's look at some examples. So in my first example, I want to use just those 2 elements that I mentioned already, sodium and chlorine. On the previous slide, we wrote out the electron configuration to figure out that sodium has 1 valence electron and chlorine has 7. But you guys hopefully remember the kind of quick trick to finding that, which is that everything in the first column has 1 valence electron, everything in the second has 2, 3, 4, 5, 6, 7, and the last column of noble gases have 8, except for helium, which has 2. So we can use that for the rest of this video as a quick way to figure out how many dots to put on our structure in the beginning. Sodium is in the first column, so I'm going to make an Na and put 1 dot on it. Chlorine has 1, 2, 3, 4, 5, 6, 7, so I'm going to make a chlorine and put 7 dots around it. The first part that I'd like you guys to show me on any of my example problems is the transfer. So that needs to show the metal giving its extra electron to the nonmetal. And you'll know that you'll be done here when the metal has gotten rid of all of its dots and all of your nonmetals have 8 dots shown, which this guy gives away 1. That starts with 7, gains 1, so it has 8. So we're ready to show the final state here, which is a sodium with no dots, but it now has a positive charge because it lost 1, and a chlorine with 8 dots, but it now has a negative charge because it gained 1. If you've done it correctly, the charges should always cancel each other out. +1 minus 1 does. And so we're finished with that. The formula, which is what you would look for if you looked this chemical up on the side of the bottle, would just be how many of each element that you used. I used 1 sodium and 1 chlorine. So this one's formula is really simple, NaCl. Let's do another example. Again, I'm going to use my quick trick to figure out how many dots to put on these. Here's calcium. It's in the second column, 1, 2. So make a calcium. Place 2 dots on in the beginning. Sulfur is here, 1, 2, 3, 4, 5, 6. So I'm going to make a sulfur, and I'm going to put 6 dots around it. So my metal needs to give away 2 dots, and my nonmetal needs to get to 8, so it needs 2 dots. So this one can work out pretty easily also. I'll show the transfer. The nonmetal now has 8 dots, had 6, accepted 2. My metal now has no dots, started with 2, gave them both away. So I'm ready to go draw the final structure with charges. Ca. In this case, it's going to be a positive 2 because it lost 2 electrons. Sulfur with now 8 dots around it, and a -2 because it started with 6 and took 2. My charges cancel, +2 and -2, so that works out. And my formula again, this is just one of each had to be used, so CaS. Alright, I'll use calcium again here on this example. So 1, 2, 2 dots. And fluorine, 1, 2, 3, 4, 5, 6, 7. So I will make a fluorine with 7 dots. This calcium again has 2 dots that it needs to give away. However, my nonmetal has 7. It's only willing to accept 1 dot to get to 8. So this calcium can give this fluorine 1, but we're not done yet because my metal still has 1 dot remaining. What you're allowed to do on any of these structures is bring in more of either elements. In this case, if I make another fluorine, which brings in 7 dots, I can solve this problem by giving it calcium's second dot. Now my metal has no dots, and both my nonmetals have 8, so I'm ready to draw the final structure. Calcium with no dots and a +2 charge. And I have 2 fluorines, each of which now has 8 dots and a -1 charge each, because each fluorine accepted 1 electron from the calcium. My charges still cancel out, +2, -1, -1 cancels out. And my formula in this case is going to be CaF2 because I used 1 calcium and 2 fluorines. Let's do one more example here. This example is as long as you're going to see on any of these problems in this class. I have aluminum, 1, 2, 3. And I have oxygen, 1, 2, 3, 4, 5, 6. The aluminum has 3 to give away, but the oxygen, since it has 6, is only willing to accept 2 of those. So again, I'm allowed to bring in more aluminums or more oxygens. An oxygen will help me in this situation. So I bring in an oxygen with 6 dots. This aluminum can now give it its last remaining dot. However, we're not finished here because this oxygen started with 6 and accepted 1 more, so currently it has 7, so we aren't finished yet. I need to make another aluminum, which brings with it 3 dots. This oxygen will accept 1 of those. Started with 6, accepted 1 from this, bringing it to 7, and 1 from this aluminum, bringing it to 8. But don't freak out. We're going to bring this problem to a quick end by adding in one more oxygen with 6. This aluminum has 2 left, and it can give both of those to that oxygen, and we've solved it. My 2 metals now have 0 dots. All 3 of my nonmetals now have 8 dots, so I'm ready to draw my final structure. 2 aluminums, no dots. They each gave away 3, so they have a +3 charge. 3 oxygens, each with 8 dots. And a 2 minus charge. And my charges do cancel out. I have a +6 and I have a -6, so that cancels. In my formula, I had to use 2 aluminums and 3 oxygens. So this shows you the variety of ionic bonds that you might have to draw on any of the tests in this class. So hope this was helpful for you, and we will talk to you later.